Okay, so we are continuing with our training. Okay, so the thing is that I have told some of you that sometimes there is this training that is HCIA security, which I do run. That is Huawei Certified ICT Associate Security. Okay, so these are the days in which this training is going to run. Okay, and of course it starts at 17:30, meaning that on these days we won't be meeting. Okay, so tomorrow we won't meet because I'm starting this new other training with Huawei security. Okay, so the same applies to next week. So next week means that we are going to meet on Monday for labs. Okay, we'll meet on Monday for labs, and then as you can see here, on these days we won't meet because I'll be taking this other training. So this is an opportunity for people to catch up, all right? A chance for people to write the chapter exams, those who haven't started writing, okay? So you can see tomorrow we're not meeting because of this training. And then on 31st, Monday, we'll meet for labs. Then I'll continue with this other training, okay? And this same training ends on 7th, okay? So meaning that other week, starting from 8th, 9th, and 10th, we will continue with our lectures, meeting, okay? All right, so, and of course, by the time I'll be having this Huawei training, maybe by then would have been done with our training. Okay. So anyway, I would recommend that you do this training after we are done with our cybersecurity training. Okay, so the goodness with this Huawei training is that it is free, okay, for now. Everything is free. Huawei, they are paying everything, to us. So this is, HCIA security is computer network security, all right? So it deals with how to protect the computer network security. Okay, so I would recommend that you do this training after you are done with our training. Okay, so let us go to our lectures. And today, anyway, let me just say that from module 5 up to module 10, this is the same topic, okay? So this is the longest topic we have in our course, all right? So today, I think maybe we'll cover 4 slides today, okay? network protocols. So in cybersecurity, it is very, very important that you understand how a computer network works, okay? From understanding how a computer network works, then you can also be able to know the abnormal behavior of a network, okay? So you find that when the network is working, the messages known as the logs are generated, okay? And it is from the logs, that is, it is from the logs where anything to do with the IP addresses are kept. So from the same logs, you can be able to tell whether one of the computers in your organization visited a malicious website and so on, okay? So very, very important that you understand networking. So the part of networking is also in this course. So a computer network is when you join two or more computers, so that you can exchange resources, so that you can share the resources, or maybe you can share information, okay? All right, now, just like we humans, we have the rules that we use when communicating, the same applies to computers. So when computers are communicating, they follow certain rules, okay? So there's no way that I can start using a different language. You won't understand, The same applies to computers. When they are connected, they have to speak the same language. Now, that language which is used in computers is called network protocols. So network protocols, these are the rules that computers must follow when they are communicating. Okay. All right. So the module objective will be, to explain how protocols enable network operations. So we have, these are subtopics with their respective objectives that must be achieved. Okay. Network communications processes. So we'll start with section 1, network communications process. So I defined a network as connecting two or more computers so that you can share the resources, or maybe you can share the information, okay? How do we share the resources in a network? For example, here at my Department of Computer Science at UNZA, you find that we have 5 offices for lecturers. And then we have the other office for our HOD. So what we did is that we just bought a single computer, which is in the HOD's office. I mean, a single printer, sorry. So we are sharing the same printer. Instead of buying individual printers for each and every office, we are sharing the printer, meaning that the printer is connected to the network. So I can print from my office, my colleagues can print from their offices, that's how you share the resources. Now, these networks, they come in different sizes, okay? And the size is determined according to the number of computers that are there. So we have smaller networks. These, they can have maybe 2 or 10 computers. And then we have also now networks for businesses and large organizations. So we find that such large organizations can have maybe 500 computers and so on. Okay. Apart from that, you find that these same companies, since they are running different types of services, it means that they can also have different types of servers. Okay, we defined what a server is, yesterday. Okay, so a server is a computer which is there to provide services to the clients. Okay, so your laptop is a client. Okay, so we have different types of servers. For example, email servers, these, they deal with emails. Okay, web servers, database servers deals with database and so on. Okay, all right, so we looked at what is known as, last time, a client-server network. So where we have the server and the client. We have also a different type of a network called peer-to-peer. Okay, so peer-to-peer is when I connect my laptop to your laptop using a cable. Okay, so what we have created there is a peer-to-peer network, meaning that my laptop can work as a client and a server at the same time. And your laptop can also work as a client and as a server at the same time. Okay, so here we have networks of many sizes. So we have small home networks. So this is a small home network where you can have 2 or 3 computers connected. And then we have small office, home office, which is this one, where you can have 10 or more computers that are connected. And then we have medium to large networks, where you can have maybe 100 computers that are connected. And lastly, of course, we have the worldwide networks. So this is the internet, which is called a network of networks. So the thing here is that the internet started as just a smaller network, okay, where I think it connected about 5 universities. So these universities, they wanted to be sharing information. So they connected those universities. But more universities were being added. Okay, until now, companies and members of the public came in. So that is how the internet grew. So the internet is made up of what is known as a local area network, a LAN. So here in our organization, in our department here, what we have is a local area network. It only covers a smaller area, okay? But if, as UNZA, we open up another campus in Kitwe, and we want to join this main campus to the other campus, which is in Kitwe, the network that we have, or what we're going to have between headquarters and that other branch, is called a WAN, a wide area network. And of course, the thing here is that this WAN is maintained by carriers, for example, Liquid Telecoms and others. But the local area network is maintained by the very organization. Okay? All right, so we have to join the the LANs, the local area networks, and then we join the wide area networks. So these, they form what is known as the internet, okay? That's how it is. Okay, we are going to learn more now on the devices, okay, that are involved for the internet to work. Okay, client-server communications, I talked about this. So here we have the client, which is your laptop, okay? When you are accessing Facebook, it means that you are accessing the servers of Facebook, okay? So what we have there is the client-server communication. So when you key in your details and so on, you press enter, the request goes to the servers of Facebook, and then they are sent to your laptop, okay? All right, so you can see here, these are clients. So this is an email client, web client, and file client. But all these can just be, on a single laptop. And then you can see we have email servers dealing with emails, web servers dealing with web services, and then file servers deals with files. So you find that all these can be in a single device, okay? All right, so the thing is that, I can even make my laptop to be a server, It just depends on the operating system I'm going to put on my laptop. So we have operating systems for clients and operating systems for servers, different types, okay? But since a server does handle different types of services, it is required to have a powerful processor to process a large amount of information. It is required to have a large amount of RAM, okay, to work with a large amount of information, okay? Typical sessions. So here are just examples of how information moves. So what we have here, this is at school. So what is happening now at schools is that people are allowed to come with their own devices. This is what we call bring your own device, BOYD. So people are able to use their smartphones to do research, to do assignments, and so on, okay? So this is what is happening. So we have Terry, and this gentleman here is connected to the school's Wi-Fi network, wireless network, okay? And Terry is using the search engine, to do research, okay? So her search is submitted wirelessly from her device to the what? To the school's network. The search data is addressed so that it can find its way back to what? Terry. So in a network, for a device, to communicate on a network, it is given an IP address. So the same applies to when you are sending a letter. What do you put on that letter? You put your address and the address where the letter is going. So when Terry here is searching, okay, of course, his smartphone will be assigned an IP address. The search string of binary data is encoded into radio waves and is converted into electrical signals, okay? that travels on the school's wired network to reach the school's internet service provider's network. Okay, so in the organization, if you want to have access to wireless network, you must have what is known as an access point. Okay, so that access point is connected to the wired network. The purpose of the access point is to send the internet signal through the air. So what Terry here is doing is that he has sent that signal. Okay, he has received the signal from the access point. You know, when he's searching, he's sending the signal to the access point. So that information, it goes now to the wired network. Okay, and then of course it has to go to the internet service provider. Okay, so here I think our internet service provider, I think it's Xamarin. Okay, so it goes now to Xamarin here at UNZA. So a combination of technologies take Terry's search, the search engine website, where the request is processed by the search engine's servers. The results are then encoded and addressed to her school. Okay, so this is how it works. All right, so encoding is changing the information from one form to the other. Okay, so here, when Telly is sending back that information to the wireless, to the wireless access point, that information has to be changed to suit a form which will be accepted on the wired network. Okay, that is what we call encoding. Okay. Then we have Michelle. So here is the lady here, Michelle. You know, she's using a gaming console to play the video game against other players. Of course, this is the video game over the internet. Her network connects to, of course, the internet service provider using a router and a cable modem that allows her home network to connect to a cable TV network belonging to Michelle's ISP. So you find that in these developed countries, you can use the same cable TV for internet. So the cable wires for Michelle's neighborhood all connect to a central point on the telephone pole and then connect to a fiber optic connection network that connects many neighborhoods served by Michelle's internet service provider. Okay, so when Michelle connects her gaming console to a company that hosts a popular online game, her action in her game becomes data that is sent to the gamer network. So the information that identifies Michelle, the game she's playing, and Michelle's network location are added to the game data. You know, the pieces of data that represents Michelle's game gameplay are sent at high speed. Okay, this is what is happening. You know, you are playing a video game, but there's a lot that makes you be connected, and of course, that process happens very, very quickly. Okay. Networking is also used in medicine, where the hospital can have cloud servers, okay, and they do access the very cloud via the network. And if maybe we are collaborating as, you know, the hospital, we have an operation, we can give access to this data via internet so that other doctors who are very far can access that information and advise how the operation is supposed to be performed. Okay. Tracing the path. So you as cyber security analysts, you have a deeper understanding of how networks operate. Because when you do understand how networks operate, then you can be able to determine the origin of the traffic, okay, as well as, to know where the traffic is going. And of course, the thing is that the traffic which is coming from your laptop, in order to reach its destination, it can use so many paths. Okay, so we are looking at tracing the path, all right? So this is the internet, what you are seeing here, which is divided into different levels, okay? Code, we have got tier 1, tier 2, as well as tier 3, okay? So tier 1 or level 1 and level 2 internet service providers, these, they connect to each other at a point which is called the internet exchange point, okay? And then we have level 2 networks, okay? We have large networks, and then level 2 networks, these, they connect at a point called the point of presence, okay? And then level 3 ISPs, they do connect us, our homes and businesses to the internet. So this is how it is. So you can see the businesses are connected to level 3 or tier 3 internet service providers. But we also have tier 2 as well as tier 1, okay? So these are some of the levels that can help us when we are tracing the source of the traffic or trying to know how our network moved, how our data moved. Okay, so this is the lab we're going to do, tracing a route. Okay. Section 2, communications protocols. Okay, so I talked about protocols earlier on. So protocols are the rules that do govern communication in computers, okay? So you find that we have different protocols here, okay? We have message size. That is when we are communicating, the message we are sending has to be divided into a particular size, okay? Imagine if the material that you are using was just a single sentence, it would have been difficult for you to understand our course, okay? So the same applies to computers. When they are communicating, the messages are divided into smaller sizes, okay? We have message formatting and encapsulation, all right? So we, the thing is, for the message to move over the internet, the headers have to be added to the message. We're going to look at this in detail so that you can understand what encapsulation is. Message encoding, as I said, this is changing the information from one format to the other format, okay? So we have wireless and wired. These are two different types of media. So when we have this wireless data, for it to move over a wired medium, it has to change. It has to be encoded or to be changed to suit the wired medium. And then message delivery options. So here, at the moment, anyway, we have 4 of them, okay, methods. Though what we have in our course, are just 3 methods of how messages are delivered on the internet. Okay, so we have unicast. Unicast is when I'm sending the message only to you in a network. And then we have mountcast. Mountcast, it is only when I'm sending a message to the ladies only in our group. Or when I'm sending the message to the men only, that is called unicast. And then broadcast is when I'm sending the message to everyone in our group or in our class. I think you have received the messages via WhatsApp. That is, if you are subscribing with Airtel, so you find that everyone who has an account with Airtel receives a message. Such a message is called a broadcast. We used to receive such messages, about Corona. Okay. And then message timing. Okay. So with message timing, let's say, we have this network where we have connected all our laptops together. So if my laptop wants to send the message, okay, how is it going to access the medium? Okay, because if my laptop sends a message and your laptop sends a message on the network, we're going to have what is known as a collision. Okay, so how my laptop is going to send the message, you find that certain techniques were developed. One of them is carrier sense multiple access collision avoidance. That is, before my laptop sends something over the internet, it has to listen to the network to find out whether the medium is free or it's occupied. Okay, that is what is called message timing. Okay. All right. So network protocols, they provide means for computers to communicate on the network. Okay. These very protocols, they have to agree on message encoding techniques which will be used, formatting, encapsulation, size, timing, and delivery options. Okay, so we looked at these, some of the networking protocols that are there. Remember when we were looking at port numbers. So we have HTTP, okay, TCP, as well as the IP protocol. So these are examples of networking protocols. Okay, so we have HTTP, which is used for web services. Transmission control protocol is used to send a message from one device to the other. Okay, and then this internet protocol, it is the one which is used by traffic when it is on the internet. So how you are able to move traffic from Lusaka to New York, you are able to do that because of the IP protocol. Okay. All right, and as you can see here, we have 2 types of IP. There's IP version 4 and IP version 6. The thing is that this IP version 4 has 32 bits, okay? And that gives us about 4 billion addresses. But you can see that the internet has grown. So we were running out of these IPv4 addresses. Therefore, they introduced IPv6 addresses. So with IPv6 here, we have 128 bits. That gives us, trillions and trillions of addresses. So at the moment, you find that your laptop is using both IPv4 and IPv6. But in future, we are going to remain with IPv6 only. Okay. All right. So network protocols message structure. So the message structure specifies how the message is formatted or how the message is structured. Okay. So you can see here, we can have this structure where we have good data. And to this data, we have to encapsulate the IP packet. Okay. So this is sending information to the server. Okay. This is the internet. Okay. So here we have the routers. So for this message to move from this gentleman to the server, which is very, very far, it has to use the IP address. So in the IP address there, we have the source IP address, where the message is coming from, and the destination IP address, where the message is going. Okay. Path sharing. So this specifies the process by which networking devices share information about paths with other networks. So the thing is, the devices that we have on the internet are called routers, okay? So these are routers. So a router is a computer, because it has the CPU and the processor. Anyway, next time I'll bring the router so that you can see it. So these routers, they share information about what they know. Okay, so this router, it knows how to get to this router. So it is going to share that information with this other router. This one will share that information with this one. That's why we are able to send the information from here to New York. It is because of these routers. They share the information about where to go. All right, that's how it is. Okay. Information sharing, just like I said. So information sharing specifies how and when errors and system messages are passed between devices. Okay. So you see, if this path is down, then this other router is going to share that information with this one and with this one, such that we don't have to use this path to send information. Okay. Session management. So this deals with the creating, okay, the managing and the ending of what are known as the sessions. Okay. So the sessions are responsible of setting up the communication. Okay. TCP/IP protocol suite. All right. So this is the TCP/IP protocol suite. Okay. It is a reference model. It is the model which makes it easy for us to understand networking, because it is able to divide the network into these layers. Okay, so you can see here we have what is known as Open Standard Protocol Suite. So this one is freely available to the public. And then we have standards-based protocol suite. Okay, so this is the one which is endorsed by the networking industry and approved by standards organization. Okay, all right. So you can see we have the application layer here. Okay, what do we have in the application layer? So this is where we have, for example, the browser, the email system. They are in the application layer. So in the application layer, this is where we have DNS. I talked about what DNS is last time. DHCP. Okay. This is where we have SMTP, POP3, and IMAP. Okay. This is where we have file transfer, okay, file transfer protocol, secure file transfer protocol, and this is the one which is recommended. Trivial FTP, this one is not recommended because anything you're doing with this is transmitted in a clear text, okay? And then we have web and web services. Now, in the transport layer, we only have two protocols, TCP and UDP, okay? When you are sending an email, when you are downloading a file, the protocol that is used there is TCP. When you are watching videos online, streaming, or when you are calling someone online, the protocol that is involved there is UDP, okay? UDP is faster than TCP, okay? Why? Because when you're sending something via TP, you have to receive acknowledgements that the information has reached its destination. When you do not receive acknowledgements, it means that data has to be resent, okay? But, so we need to track the conversations and so on, the information. So we have a number of techniques, but with UDP, we have no acknowledgements. Even though data has not reached its destination, that data doesn't have to be resent. Okay. And then this is the network layer. So here we have the internet protocols. IPv4, IPv6.
So just a minute. I don't know. I wanted to find out the initial for UDP.
This is user datagram protocol.
Okay. All right.
Yeah. User datagram protocol. Okay. So now here we have IPv4, IPv6, network address translation. Okay, NAT. Okay, how NAT works is like this. So as I said, we were running out of IPv4 addresses. So somebody came up with NAT. So with NAT, two types of addresses were developed: private addresses and public addresses. Private addresses are those that are used within the organization. So these private addresses can be used or can be given to computers in so many organizations, the same ones. Okay? So a computer which has a private address, it cannot communicate on the internet. For it to communicate on the internet, it has to be given the public address. So that process of changing the private address into a public address is called NAT. Okay. And then we have messaging protocols here, ICMP. Remember, we used ping, okay, last time. So ping uses ICMP protocol. So you can see we have got ICMP for version 4, ICMP version 6, and ICMP network discover. And then we have these routing protocols. Now, I said that on the internet, what you have there are routers. So how do these routers share the information? They share the information through these routing protocols. Okay, so with routing protocols, again here, we have interior routing protocols. For example, OSPF and EIGRP. EIGRP is CISCO's, and then OSPF is international standard. Okay, now, interior routing protocols, for example, within XAMTEL, they only use interior routing protocol. So we have got XAMTEL, and here we have got Liquid Telecom. If these two want to communicate, then they use exterior routing protocol, and we have got only one, which is the border gateway protocol. Okay. Network access layer. So this is where we have the ERP, address resolution, data link protocol, Ethernet, as well as wireless local area network. Okay. We are going to look at ERP as we are going, what it is and so on. But address resolution, the thing here is that in the local area network, okay, the computers, when they are communicating there, they don't use IP addresses. They use MAC addresses. Okay, so you see, my laptop and your laptop are connected in a local area network. But my laptop only knows your IP. I don't know your MAC address. Therefore, I can't send information to you. So for me to send information to you, I need to know your MAC address, which is the physical address. So what my computer is going to do is to send a broadcast. Okay? You remember, I said, what is a broadcast? Is a message which has to go to all the devices. So this broadcast is going to be sent. Okay? So this device is going to receive the broadcast, open it, and compare the IP address there with its IP address. If they don't match, it means that that message is not addressed to that computer. So it is going to be dropped. Okay. Now, when the message reaches your computer is going to open, compares the IP address in the message with its IP address. If they match, it is going to reply now with its MAC address. So this is how my laptop is going to know the MAC address of your laptop. After I've known, that's when now my laptop is going to send the information to you. So that process is called ERP. Okay. All right. Okay, so, we looked at DNS, what it does, okay, translates domain names into IP addresses, okay, and then DHCP is used to assign the IP addresses automatically, okay. So we have DHCP version 4 for IPv4 and DHCP version 6 for IPv6, okay. And then with IPv6, we have also what is known as SLAC. Okay, so this is stateless address auto configuration, which is also used to assign the IP addresses automatically to the devices. Okay, email protocols, these are the email protocols. I've talked about these already. So when
You've got a question?
yes.
In what instances do you use Slack?
You can configure. It's up to you. If you configure it, you configure Slack on those routers, then the devices will be assigned the addresses automatically. It is up to you. If you want, you can just use DHCP version 6. So it doesn't.
What's the difference between the two?
Anyway, the difference between the two, you find that the thing is, what is happening out there, you find that Slack is configured together with DHCP, okay, where the device is going to get certain parameters from DHCP version 6, and then it's also going to get other parameters from Slack, okay?
Okay, sir.
But there are some cases where you just only configure Slack. Okay, so this is just a feature which was added. So it is up to you. If you want, you can configure just Slack. There's no difference at all. If you want, you can just configure DHCP version 6. Okay. Yes, go ahead.
I know I wanted to find out. So like when configuring a router, or
Yeah.
does it mean that you can actually get certain IP addresses and then just create, you can, what can I say? You can customize your own routing table.
Yeah. Okay. So now that is now networking. Okay.
Okay.
When you are configuring DHCP, you create a pool of addresses. Okay. When we're using Slack slightly uses a different method where it has to use the your MAC address, and then it has to add a certain value for it to come up with the IP addresses. So you can, but of course, the thing is, when you go to Liquid Telecom, what you're going to buy is a block of addresses that you're going to use. So just can't use anything anyhow, but you have to use something that is within the block which has been assigned to your organization. Okay? Okay, I hope I'm clear. All right.
Okay.
Yeah. So when you are sending an email, the protocol that is involved is SMTP. When you are receiving an email, the protocol that is involved is POP3 or IMAP. The difference between these is that when you receive your email, that email will be deleted from the server when you're using POP3. But when you use IMAP, when you receive an email, that email will still be on the email server. Okay. File transfer involves these protocols. We looked at this, but we didn't look at SSH file transfer protocol. So this is the one which is recommended because, traffic, whatever you're sending is encrypted. Okay. I like the way the material has been done. At least here students will be able to, really understand the definitions and so on. So some of you have written chapter exams. You have seen that we have multiple choice, and then we also have drag and what? Drag and drop. Okay. So you have the words, and then their definitions. So you select the word and you drop it on the correct what? Definition. So I think this will help. Okay. HTTP, this is used for web services, but the one which is recommended is this one. And then we have REST, which is representational state transfer. So this is a web service that uses APIs and HTTP requests to create web applications. Okay, so the reason why you see REST here, it wasn't there because you find that now in networking, we need to know programming, especially Python. Okay, so the use of REST APIs and so on. Okay. All right, so that is the application layer. Now, the transport layer, we have TCP. So TCP is connection oriented, meaning that before information is sent, the connection has to be established, okay? TCP is reliable because when we lose information, that information has to be resend, okay? UDP is connectionless. It means that no connection has to be established. You just have to send information. And UDP is called unreliable because when you're using UDP and we lose information, that information doesn't have to be resend, okay? Okay, internet layer. So this is where we have internet protocols. So you can see we have IP version 4, as I told you. Here we have 32 bits. So IPv4 has 32 bits. That is going to give us about 4 billion addresses. So when they were coming up with the internet, they never thought that the internet would be this big. So a number of addresses have been used. Therefore, somebody came up with IPv version 6. Okay, so this has got 128 bits. When you do some calculations, this is going to give us trillions, trillions, and trillions of addresses. Okay, NAT, network address translation. So this is, the technique which translates addresses from private network into global unique public IP addresses. I did explain about this. So NAT makes it possible for us at UNZA internally to use the same IP addresses as CBU, ZCAS, a lot of organizations. So at least in such a way, IP addresses were increased somehow, because the same IP addresses can be used by a number of organizations. Okay. Messaging. So we have ICMP version 4. So this is used, to provide feedback from a destination, whether we have errors and so on. Okay. So IPv6. Because we have got IPv6, therefore we also have ICMP version 6. Okay, so this has got similar functionality to ICMP version 4. But of course, it uses what? IPv6 packets. ICMP, network discover. Okay, so this is used for, network address resolution, as well as to find out whether any other device in a network is using the same IPv6. Okay. Routing protocols. So we have OSPF. So OSPF is a link state routing protocol, and it is also interior routing protocol. I did explain this. So interior routing protocols are those that are used within the organization. So routing protocols that are used, at Zamtel, they are called interior routing protocols. So they could be using OSPF, okay? And then EIGRP, it is the one which is used on CISCO routers. This one is also interior. So this one can be used maybe by iConnect, okay? Now, when you want to connect iConnect to Zamtel, the routing protocol that you use there is exterior routing protocol. And we only have one, we only have the BGP, which is the border gateway protocol. Okay. Network access layer. So this is where we have address resolution protocol. As I said, it provides mapping between IP addresses and hardware address. So this hardware address is called a physical address, or it's called a MAC address. So each and every laptop has got a unique hardware address, or physical address, or MAC address, okay? Data link protocol, so this is where we have got Ethernet, okay? So a local area network is called, it is using Ethernet or Ethernet technology. And we also, this is where we have wireless local area network. So now, the wireless local area network, it just extends the wired network. Because what happens is that you have to get the access point. That access point has to be connected to the wired network. The purpose of the access point is to send the wireless signals so that you can have wireless, network. Okay. Communications protocols, message formatting and encapsulation. So when you are sending a message over the internet, it must have a particular format or a structure, okay? And the format, of course, depends on the type of the message and the channel that you're going to use to deliver that message. So here we have an analogy, okay? Which analogy, okay? So this is something that we use to try to demonstrate something, okay? And you see, let me go back. So, we have animations in the material, okay? Which can help you to understand. So the analogy that we're going to use here is a letter, okay? So on the envelope, you're going to put addresses. The address of the recipient, which is destination address, and then the address of the sender, okay? So this is, the address where you're sending the letter to. And then this is your address, okay? So in the letter you have salutation, dear recipient, maybe the name, content of the letter, this is encapsulated data, the message you're going to send, okay? Sender, source identifier, okay, your name, and then this can be the end of the frame or the end of the message indicator, okay? So how you end the letter, how you write the letter, whatever you are doing with the letter, that is exactly how computers do it, okay? So the process of taking that letter and putting it in an envelope is called encapsulation. When the receiver receives the letter, he removes the letter from the envelope. That process is called decapsulation, okay? All right. Okay, so this is, we're talking about the message format, okay? This is an IPv6 header. Okay, so how do we format this in computers, or what do we have in the header? Yes.
Yes, sir.
Yes, sir.
Please, I wanted just to inform you that I didn't attend the test. So after today's class, you should just send me the link so that I write my test. I was out of network, so that's when I'm coming back.
Oh, the chapter exams are already active. Do you know where to find them?
Okay.
Yeah, let me.
No, I think you can just. I think after today's class, you can just send me the chapter so that I find them.
No. Let me show you. Hold on. Let me show you, sir. Let me show you. Are you able to see this? Let me show you. Anyway, sorry for disturbing this one. Mr. Chomba.
Okay, sir.
Mr. Chomba, listen.
Okay, sir.
Now look here. Are you able to see this class here?
Yes, I'm able to see them.
So when you log in, this is what you see, Mr. Chomba. Okay?
Okay.
Then here, assessments, you click assessments.
Okay.
Once you have done that, have you seen? So when you read module
Yes.
1 and module 2, and you think that you are ready, then you click this exam. So what is going to appear is a page where you're supposed to click start exam. Is that clear to you?
Yes, sir.
Yeah, so you see,
It's clear, sir.
yeah, now, so everything is here, you know. Then when you are done studying module 3 and 4, you come to this exam, you write it, and so on, okay, until up to here, okay. I think you have seen, okay.
Yes, sir. I've seen.
Okay, fine, okay. So similar to sending a letter, a message that is sent over a computer network follows specific format rules for it to be delivered and processed. You know, we have the internet protocol, you know, with similar function to the envelope example. So the IP is responsible for sending a message from the message source to destination over one or more networks. Okay, so in the header of the IPv6, this is what we have. Have you seen here? This is source IP, and then this is what? This is destination IP. So the messages are divided into smaller chunks. So a single chunk or a packet has the source IP address and the what? Destination IP address. Okay, that's how it works. Okay, then message sizing. So you find that, as I said, the messages will be divided into smaller sizes. We have an analogy here. You know, this gentleman is talking to the lady. Okay, so maybe the lady is very, very far. You know, and the gentleman has asked the lady to describe the weather. This lady, when explaining, you know, should be explaining, pausing, you know, and so on. There's no way that this lady can just keep on talking, you know. Then the gentleman won't be able to understand. Okay. So this is an analogy, you know, something which can help us to understand how the computers do it. Okay. All right, so you find that the messages are divided into smaller chunks. Message timing, this is where we have flow control. What is flow control? This is when my laptop is sending information to your laptop at a very faster rate that your laptop is not copying. So your laptop is going to send a message to my laptop saying, relax. That is flow control. And then response timeout. This is the time in which when I've sent something to your laptop, for how long am I going to wait before resending? Okay. And then access method. That is when I have connected my laptop to your laptop. Okay. How is my laptop going to send the information? First, my laptop has to listen to that medium to find out whether you are sending or not. That is access methods. Because when my laptop sends and your laptop sends, we're going to have the collision. Once we have the collision, then that information will be destroyed. Okay. How the message is delivered, I've explained about this. Unicast, this is one-to-one. So it means that this is sending the message only to the printer. Mountcast, okay, this router here is sending the message only to this particular group. I gave an example. In our class, when I'm sending the message only to ladies, that is called Mountcast. And then broadcast, when I'm sending the message to all the devices, okay? In our class, when I'm sending the message to each one of you, okay? All right. Okay, so, the network is very, very complicated. For us to understand the network easily, we have to use the layered models, okay? So the benefits of using the layered model is that they do assist in protocol design, okay? Fostering competition, because, when we have these competitors, they are making laptops, okay? They are maybe making wireless access points. When designing all those, they need to follow the standards, okay? So my laptop can be Dell, but the access point can be for Huawei, but I can still be able to connect to that laptop, because when designing the laptop, when designing the access point, they have to follow these models, okay? Preventing technology or capability changes. So the thing is, when we have changes in the application layer, when we're changing something in the application layer, that won't affect the presentation layer and so on and so forth, okay? And then of course, they promote a common language. So we have two models that are there, the OSI and TCP/IP. Of course, the model which is used is TCP/IP, okay? So this is the OSI model. So the OSI model, as you can see, has 7 layers, okay? So when you see the physical layer, what should come into your mind are the cables. When you see the application layer, what should come into your mind are the browsers and email systems and so on, okay? Now, this is the TCP/IP model. So we have to combine these 3 to make one. The transport layer remains the same in both models. The network layer becomes an internet layer. And then these 2 are combined, data link and physical are combined into network access in the TCP/IP model. But you can see they use the same protocols here. Okay. All right, so the thing is that each and every layer has a particular function that it does, So when we understand each and every layer, then it'll be easier for us to understand networking, okay? So the application layer, it contains protocols which are used for process-to-process communication, okay? Presentation layer is used for data encoding encryption and data formatting. Session layer is used to create sessions, manage sessions, and ending those sessions. The transport layer is used to make sure that, you know, we have end-to-end communication, okay? Segmentation, what is the segmentation? This is the process of dividing the data into smaller chunks, okay? The sending of that information. Now, with TCP, as I said, when you're sending something over the internet, you find that data can be using this link, but something can happen to this link. Data will start using the other link, and so on. So you find that the data is going to reach at the destination in the order which is not the order that we want. For example, we can be sending the data packets in the order 1, 2, 3, 4. So we have, let's say, 5 segments, okay? 1, 2, 3, 4, 5 segments. Now, the receiver can receive that information let's say, starting with the 5th segment, 2nd segment, you know, 1st segment, and 3rd segment. So what TCP does is it has to reassemble those segments to be in the order in which they were, okay, in the order 1, 2, 3, 4, 5, for the device to understand, okay? But UDP does not do that. UDP does not reassemble the data, okay? Networking, so this provides services to exchange the individual pieces of data over the network. And then the data link, this describes method for exchanging data frames between devices over a common media. And then the physical layer, of course, this describes the mechanical, electrical, functional, procedural means to activate, maintain, deactivate physical connection. All right, so very, very important that you know the functions of each of these layers. So of course, you're going to be tested on all these through drag and drop. You know, the reason of having those exams is to make sure that you are fully baked. And then you can see the application layer and their functions just similar to the OSI. Okay, data encapsulation. Okay, so segmenting a message is dividing the message into smaller components. And then multiplexing is we are using the same media for data which is coming from different sources, okay? So what are some of the benefits of dividing the information into smaller chunks, okay? We are going to increase the speed, and we're also going to increase the efficiency, okay? All right. That is when you say efficiency, it means that a large percentage of information we are sending is going to reach its destination. Okay. All right, so this is multiplexing. Oh, no, this is sequencing anyway. So you find that when we are sending the data, you know, tags has to be placed on the data. Of course, on this same, you know, chunks, we have the source and destination emails. And also we need to put a sequencing number, okay? All right, so that, of course, this is TCP. So when we do not receive a certain sequence, that message has to be sent, okay? To resend the information, okay? PDUs, protocol data unit. So this is the smallest piece of information that we have in networking, okay? So, you know, you are sending something over the internet. what you have is email data. So this is the application layer. Now, when this data reaches the transport layer, to data, we are going to add the transport header. So this process of adding the header to data is called encapsulation. So that process of putting a letter into an envelope, okay? So once we have done that, this is no longer called data. It is called a segment. So the protocol data unit that we have in the transport layer is called a segment, okay? So this segment, when it reaches the internet layer, we are going to add the network header. Now, here, let me just take you back. In the transport header, what are we adding to data? What we are adding are source and destination port numbers. Remember, we talked about that. And then here, we are going to add the network header to the segment. This process of adding the header is called encapsulation. What are we adding? What we have in the network layer, in the network header, sorry, is the source and destination IP address, okay? So the PDU in the internet layer is called the packet. So this packet, when it reaches the network access layer, we are going to add the frame header. What do we have in the frame? What we have in the frame is the source and destination MAC addresses, okay? So the PDU that we have on the network access layer is called a frame. So now, when, of course, computers only understands ones and zeros. So these ones and zeros will be changed into the signal when we move over the cable. Okay. So if you noticed, we have three types of addresses. The port addresses that we have here, okay? And then we have the IP address here, and then we have the physical address here. So three types of addresses, okay? Now, the physical addresses, they are used on a local area network, okay? When we go to the internet, we have to use the what? The IP addresses, okay? The port numbers, of course, they are used to make sure that, when you open, a certain application, what is going to be generated will be a source port number automatically. But the destination port number is fixed. So when you connect to the internet, the reply has to come back the source port number. All right, so that is what happens when you are sending information. So when you are sending information, we are starting from the application layer going down, okay? When we reach the receiver, we'll start going up. So here, when we are going down, we have to be adding the headers. That process of adding the headers is called encapsulation. But when we'll be going up, we'll be removing the headers. That process is called decapsulation, okay? So this is what is being explained here. Okay, so that is the lab, we are going to do. That is that with this module. Okay, do we have questions where we are stuck? You have to be free. You talk. Very, very important.
So
Yes.
on the OSI reference model,
Yes.
talked about adding headers and the like. For IP version 6, I'm
Yeah.
told it's already in binary. So is that process still the same?
It is still the same. We still follow the same. It is still the same. We still follow the same protocol stack. Okay. So what has changed there are just the addresses, but everything remains the same. Okay. So have you seen time has gone? We have just looked at, one module. Let us do this one as well. Modules, no, am I correct? Yeah, yeah. Module 6, Ethernet and Internet Protocol. So as I said, this is the longest chapter, okay? Ethernet. So Ethernet is what is known as LAN technology, in a building, a single building, okay? Like in our department here. The network that we have uses Ethernet, okay? So Ethernet uses 802.3 standard, okay? And then here, you can see this is the data link, which is divided into logical link control and media access control. Why? Because this layer here has more functions than any other layer. And Ethernet supports speed from 10 megabits per second up to 100 gigabits per second. Okay. Now, the Ethernet frame, these are the components that it has. So you can see, have you noticed, where are we starting from? We are starting from, below the model, will be going up, okay? So in OSI, the physical layer is also called layer 1. Data link is called layer 2, and so on, okay? But you can't use the same language we are dealing with TCP. So we are going up. Therefore, we started looking at the frames. So the minimum size of a frame is 64 bytes, okay? When we have less, it means that the computer will drop that frame. And then this is the maximum size. When we have more, the computer is going to drop that frame. So this is how the structure of the frame is. You have the preamble, which is used for synchronization. And then what do you have? Destination MAC address, the physical address. And then we have also the source MAC address. And then this has to do with the type of the protocol that we're going to use in the next layer. That is in the network layer, which protocol we're going to use. And then here, this is the data which we are going to transmit, okay? And then this is the frame check sequence, which is used to check for errors in the frame, okay? So you can see, as I said, the preamble or the start frame delimiter, it is used for synchronization when the frame is being sent, okay? Start frame delimiter shows us where the frame is starting from. So we have where the frame is starting from and where the frame is supposed to end, okay? So we have destination MAC address, of course, where we are sending the frame to, the source MAC address where the frame is coming from, and then type, as I said, this talks about the upper layer protocol, which we are going to use, okay? Data field, the actual information that we are moving, and then the frame check sequence, is used to detect error using what is known as the CRC. Okay, now the MAC address has 48 bits. The first 24 bits are used to identify the manufacturer of that device. So by just looking at the first 24 bits, you can be able to tell that this laptop was made by Samsung. This laptop was made by HP. Then the last 24 bits are used to distinguish those devices which are made by HP and so on. Okay. So this MAC address uses the hexadecimal numbering system. This is a numbering system which starts from 0 up to 9, and then followed by letters from A up to F. We use this numbering system to shorten the length of the address. So your MAC address can either use dashes, or it can use colons, or it can use periods. Okay. IPv4. All right. So you see, we are moving. This is layer 1, layer 2, layer 3. We are, following the OSI model. So we are going up. So we are now here in the network layer where we have IPv4 and IPv6. Okay. So this is used for routing, on the internet there. This is where we have OSPF, ICMP. Okay. So the basic operations of this layer is addressing end devices. That is assigning IP addresses. Okay. As well as encapsulation. Okay. So when a router receives the packet, it is going to open the packet and check the IP address. If it is not addressed to it, it is going to close it, and so on. Okay. Routing. So of course we have got so many routes or so many paths which can be used over the internet. So the router has to come up with the best path to use. Okay. As well as decapsulation, that is after the router has opened the packet, it has to close the packet as well. Okay. So you see, when you're sending something, so this is the internet. The internet is nothing other than the connected routers. Okay. So this is where we do routing. Okay. The router has to calculate the best path and so on. Okay. All right. So we looked at the encapsulation already. So this is where we take the IP header and we add it to data. What we have in the IP header are the source and destination IP addresses. So what are some of the characteristics of IP? The first one is that it is connectionless, meaning no connection has to be established when we're using the IP. This function of establishing, it is done by the other protocol, for example, TCP. The IP doesn't do that. And then the IP also uses what is known as best effort. So with the IP, we don't have acknowledgements. Acknowledgements are fulfilled by the other protocol, which is the TCP. The other characteristic of IP is that it is media independent, meaning that the IP can use airwaves, wireless, fiber optic, or a copper cable. Okay. So this is an analogy of connectionless. That is, when you are receiving a letter, you don't know whether that letter is coming to you, but you receive it. You are not informed. Okay, so this is connectionless analogy of connection relation. Okay. Okay, so for best effort, of course, here, when we're sending IP, we don't, expect acknowledgements to be received. Okay. Media independent, meaning the IP can use copper Ethernet cable, copper serial, optic fiber, copper Ethernet, as well as what? Wireless. Okay. So very, very important that you also, understand the IP header. Anyway, let me end here because, we have looked at a lot of stuff today. So just like I was saying, and I did inform some of you that I also have another evening training which is going to start tomorrow. Okay, so these are the days that I'll be having this training, meaning that on these days, we're not going to meet. As I said, tomorrow we're not meeting. I'll start this Huawei training, and you can do this training as well. So this is computer network security. You can do this training as well after you are done with my training. So I'll still be, doing this training. I don't know up to when. As long as we have COVID, I'll still be doing this training. So meaning tomorrow, we're not meeting. Okay, we'll meet on 31st for the labs. Okay, so you can see here, we won't meet, but we'll meet on 8th, 7th. We're going to start meeting on 8th, 9th, 10th, and so on. We're going to be back to our schedule starting from 14th September. And then by the time I'll be having this other training, by then we'll be done, okay, with our training. So thanks very much. I really appreciate that you have attended. And those who haven't yet started writing chapter exams, this is the time when you'll be given this free time to study and write the chapter exams. And again, you can also move at your own pace if you want. You can be done with the training within a month. It is up to you. Like in the previous group, I think, someone was done within a month. Anyway, it is up to you. Do we have questions? Okay, anyway, good night. If you have issues,
All right.
if you have issues, you can contact me, okay?